Summer 2017, Arecibo, Puerto Rico. Astronomers using the iconic radio telescope witness a repetitive signal. It's radiating from the direction of the Virgo constellation. It has all the characteristics of intelligence. It seems to be coming from a small, red dwarf star named Ross 128. And it's just 11 light years away, one of our nearest cosmic neighbors. "5,300 kilometers to the south, on a Chilean mountaintop, the 3.6-meter La Silla Observatory is completing more than a decade of monitoring that same star. In those data, a stunning detection. There is an Earth-sized planet orbiting Ross 128. And it resides in the habitable zone where life, sustained by liquid water, is possible. Now, wielding sensitive new instruments, planet hunters are suddenly finding thousands of new worlds all over the sky. But have any of them sprung to life? Or are we on Earth, lone orphans of the universe? Look up at the night sky. Pick any star. According to astronomers, it probably has several planets in orbit around it. And there are many more stars out there than meet the eye. The most common star type in the universe is the red dwarf, also known as the Class M star. They're hard to see, small, lightweight, cool, and faint. But these conditions actually make it easier to find exoplanets orbiting around them. Because red dwarfs are petite, the wobbling motion caused by their planets gravitationally tugging on them is larger, so it's simpler for instruments to detect. Because they're low in mass, the planets orbit close in. Their years go by in just a few days, so it's easier to see the wobble pattern repeating. And passes across the face of the star, called transits, happen much more often. Because they're cool and faint, there's less glare, so planets are plainer to perceive. Proxima Centauri, our stellar next-door neighbor, is just such a red dwarf. It's puny, just 12% the mass of the Sun, and less than 14% as big. It's only about 1% as bright, so it's relatively cool, only about 3,000 Kelvin. Our Sun is nearly 6,000 Kelvin. And after extensively studying the star for more than 16 years, astronomers have confirmed at least one small planet dwells there. Proxima Centauri b. It's at least 1.3 times more massive than Earth, probably dense and rocky like our world. which would make it about 10% bigger. It orbits its parent star once in a little more than 11 days, revolving at the distance where water could be liquid, as well as solid and gas, just like Earth. But there's a problem with that star. Like many red dwarfs, Proxima Centauri has a stormy temperament. Large flares, blasting X-rays, bathing its system of worlds in deadly radiation, eroding away any life-supporting atmospheres they may have. And there are problems with that newly found planet. Although it's in the so-called Goldilocks zone, Proxima b orbits only 7.2 million kilometers from the source of that radiation. That's 21 times closer to its star than we are to ours. Because Proxima b doesn't rotate, it may have no magnetic field, nothing to ward off the onslaught of lethal energy. To anyone standing on the surface of that world, the irate red star would look 10 times larger than our sun does to us. More concerns. The planet doesn't tilt like ours, and its orbit seems to be nearly circular, which means it doesn't have seasons. Earth's changing climate and relatively rapid rotation of day into night likely stimulates the continual evolution of life. Proxima b is much less dynamic. It's probably in tidal lock with its star. Like our moon, it always shows its parent body the same face, so it may have a warm day side, which would bear the brunt of the flares coming off the star, and a cold, frozen night side. The view from that night side would be dominated by two dazzling stars, Alpha Centauri A and B, forming a triple system with Proxima, each tens of times brighter than any stars in the night skies of Earth. But there may be no one there to see them. If you go a little further out from Earth, the news gets better. Ross 128, only 11 light-years from us, is one of the quietest red dwarfs known. It discharges hazardous radiation much less often than its sister M stars. The High-Accuracy Radial Velocity Planet Searcher, or HARPS, has been looking at Ross 128. Combing through 10 years of data, astronomers recently confirmed a rocky planet gliding along in the star's temperate zone. Dubbed Ross 128b, the small dense planet looks to be 1.35 times the mass of Earth, much like Proxima b. And similar to the planet at Proxima, Ross 128b orbits about 20 times closer to its calm and cool star than does Earth to our hotter sun. Its year is just 9.9 days long. This planet may offer the closest, most comfortable environment of any exoplanet found so far. But that's not conclusively proven. The Ross world may be more like Venus, holding a high-pressure atmosphere that's too hot for life. And what about that intriguing Arecibo radio signal? The celebrated Green Bank Telescope in West Virginia and the SETI Institute's Allen Telescope Array in Northern California both took a long, hard look. The repeating signal wasn't seen again. Researchers' best guess is that was most likely a reflection of pulses from one or more communications satellites in geostationary orbit around Earth. But though there's no proof of intelligence, astrobiologists remain enthusiastic. This, they say, is the right kind of place to look for life. Small red M dwarfs live hundreds of times longer than sun-like stars. If primitive life can get a toehold on a world near one, there's plenty of time for evolution to learn to cope with harsh conditions. Red dwarfs are opening up new possibilities of finding habitable worlds just when planet discoveries around more familiar stars seem to be shutting them down. Scientists will invent different schemes for detecting alien planets. Most successful so far, at least in terms of raw numbers, is to task a space telescope with persistently staring at a rich patch of stars. Launched in 2009, the remarkable Kepler mission watches for the slight dimming of a star when a planet sails across its face along the line of sight between the telescope and the target star. Kepler astronomers and citizen scientists have spotted several thousand new planets using this transit technique. Thousands more are waiting to be confirmed by seeing them pass a second or third time, establishing the planet's orbital period. So, the longer humanity looks, the more worlds we'll probably see. In slower, wider orbits, more distant from their suns. The searches to date have mostly netted large diameter planets, most of them very close to their stars. Big worlds, transiting often, are beginning to divulge the secrets of their atmospheres. Astronomers are practicing on these worlds, learning to spot molecules like methane, nitrogen, carbon dioxide, water, and oxygen, which could be products of active life, so-called biomarkers. A surprising number of these globes are truly gigantic, super-Jupiters, between 8 and 14 times heavier than our own. Earth and Venus are up to 1,000 times smaller and 2,500 times lighter in weight, altogether much more difficult to spot. Some planets lead truly bizarre lives, like this extra-hot gas giant, HD 1897-33b. It orbits so close to its turbulent star that periodic flares tear off large chunks of its atmosphere. Researchers call this a torch orbit. NASA's Swift satellite and the Hubble Space Telescope watched as the planet temporarily grew a tail like a comet. Big as it is, over millions of years, this huge world will erode away. Some worlds, like Scorpion 1b, inhabit multiple star systems feeling the complex gravitational interactions of 2, 3, or more massive bodies. And this one, HIP 13044b, is an immigrant planet. It came in with its parent star from outside our galaxy. This dramatic diversity among exoplanets has astronomers scratching their heads, but planet hunters believe they've barely scratched the surface of the sky's hidden treasures. One quick way to tell if a planet might be Earth-like is to check the color of the light bouncing off of it. If you look in color space, Earth sits off on its own, a lone wolf, away from its solar system siblings. Some researchers rate worlds with an Earth Similarity Index, the ESI, a number ranging from 0, nothing like Earth, to 1, exactly like Earth. To qualify as a true twin to ours, it's not enough for a planet to be the same mass, or the same size, or even in the habitable zone. In 2007, the HARPS team at La Silla picked up the first evidence of a planet in the habitable zone of its star, a red dwarf named Gliese 581, 6 times more massive than Earth, and rotating so slowly its day is perhaps 70 of our days long. Gliese 581d may globally warm itself with greenhouse gases. So it could be an ocean planet, the first one spotted. If so, it probably began as an ice giant further out in the system. Kepler 22b was the first exoplanet that mission scientists found in the temperate zone of a star like ours. That star is just slightly smaller than ours. But the planet is bigger, about 2 times Earth's diameter. The transit method isn't very good at pinning down planetary masses, so we don't yet know how it weighs in compared to Earth. Researchers speculate it may be a water world, a deep global ocean clinging to a massive rocky core. "22 light-years out in another direction, Gliese 667cc swings round a cool red M dwarf in just 28 days. At that distance, the star looks 3 times wider than our sun does to us. And you'd see 2 other prominent lights in that sky. The star has 2 nearby sisters. The planet is massive, maybe 5 times Earth's mass. Standing on its surface, if it has one, you'd weigh 1.5 times what you do at home. But it's possible you'd feel right at home in other ways. Gliese 667cc could be habitable. %10 larger than our planet, Kepler 186f lives just within the outer edge of its star's Goldilocks zone. That star is a red dwarf about 500 light-years distance. 4 larger, hot, and presumably lifeless planets ride closer in to the dwarf. 186f is roughly Earth-sized, perhaps just 11% larger. But it's probably colder than Mars. In 2013, a pair of planets surfaced in the Kepler data. 62e and 62f circle their cool star in orbits where plenty of water could flow. The inner one is likely a totally wet world. The outer, a super-Earth, 1.5 times our size, could be cooler and drier. Now, imagine a cloudy world where you weigh at least twice what you do on Earth. Kepler 452b, sometimes called Earth's cousin, is probably rocky like us and 1.6 times our size, but it may be up to 5 times more massive. 1,400 light-years from us, it orbits a G-type star very much like our Sun. It's 20% brighter, but the planet rides a bit further out from its star. The Kepler 452 system is 1.5 billion years older than ours. Evolution has had more time to work. It was long thought that the most likely place for life would be an Earth-like planet circling a Sun-like star. But in 2017, a system full of surprises came to light. A tiny star not much bigger than Jupiter, hosting 7 rocky planets, all about the same size and mass as Earth. The TRAPPIST-1 planetary system takes its name from the project that discovered it, Transiting Planets and Planetesimals Small Telescopes. It's a pair of surprisingly petite robotic scopes. They're perched on a Chilean mountain, but controlled from Belgium. NASA's Spitzer Infrared Space Telescope helped confirm the find. When a star isn't bright, a small Earth-sized world transiting across its surface makes a big difference, a proportionally larger drop in the light curve. 40 light-years out, the ultra-cool dwarf named TRAPPIST-1a glows a deep red. It's just 11% the diameter of our parent star, so it puts out merely 5/100ths the Sun's light. Though it's dim, the dwarf provides more than enough energy to set up a habitable zone, and at least 3 of the newly discovered planets orbit within it. TRAPPIST-1f is likely the best positioned for life. The red sun in its sky would look larger than ours does to us, but less than 100th as bright. It could be warm there, though. Like tussling siblings, 7 worlds so near to one another probably jostle one another's orbits. They try to keep in resonance. Their orbital periods pulled into whole number relationships. But those gravitational tugs could power up tides, keeping these worlds warm, mixing the chemistries that lead to life. The TRAPPIST-1 system has had a long time to brew. The little star could be more than twice as old as our Sun, and it could live at least 10 times longer. Like Ross 128, TRAPPIST-1 is a quiet dwarf. its ultraviolet radiation wouldn't strip the atmospheres of the planets in its habitable zone for perhaps 15 billion years. The search for nearby worlds that may be like our own is accelerating. Large arrays of millimeter and submillimeter wavelength dish antennas, like this one in the high, cold Atacama Desert, are revealing how baby planets grow within the dust disks of young stars. The giant Magellan Telescope at La Serena, Chile, with a segmented primary mirror 24.5 meters across, and the extremely large telescope, also in Chile, but at Cerro Amazones, with its nearly 40-meter-wide aperture and laser-guided adaptive optics, will try to take direct images of exoplanets, at least 5 times sharper than the Hubble Space Telescope. Their monster mirrors take years to cast, cool, and polish. Above Earth's atmosphere, NASA's Transiting Exoplanet Survey satellite, TESS, will search all over the sky, looking at the brightest and nearest stars, at least 200,000 of them, with the objective of spotting Earth-sized and super-Earth-sized planets. Europe's Plato satellite will investigate as well. New space-based observatories, like the James Webb Space Telescope and the Wide Field Infrared Survey Telescope, should be able to identify the composition of many exoplanets' atmospheres. They'll look for telltale signs of biology, the exhalations of life, in the gases around these worlds. Like a small bird flying near the landing lights of a large airplane, planets moving near stars are tough to see. Astronomers are now perfecting devices called coronagraphs, which simulate the effect of an eclipse, blocking out the glare of nearby stars to reveal planets they may host. If an alien world is young and bright enough, and far enough away from its star, such instrumentation can directly image it. These sensitive detectors may be able to make out what's in the atmospheres of the nearby habitable zone-dwelling Earth-sized worlds, like Ross 128b, Proxima b, and the TRAPPIST-1 planets. Evolution of biology on Earth dramatically changed our planet's atmosphere, setting up a feedback loop, making conditions even more hospitable to life. With a similar level of technology to our own, astronomers on any of those alien planets could tell that we are a living world. On the scale of human distances, even the closest stars are almost unimaginably far away. humanity's farthest rocket-powered probes are only now just leaving the solar system after 4 decades. But a bold plan to dispatch a fleet of tiny, low-mass nanoprobes across the interstellar abyss to Proxima Centauri has just been launched. Driven by a constant, coherent column of light from a square-kilometer phased array of 10-kilowatt lasers, together pumping out about 100 gigawatts, the swarm of sails would be propelled outward from Earth, fast enough to fly by the nearest star system in about 20 years. Aboard each light sail rides a tiny package of science instruments, including cameras, plus communications module, a minuscule radioisotope battery, and a photon thruster for maneuvering, all weighing no more than a few grams. They're called star chips. 1,000 such craft would be deployed at a time. It's a long way to travel, and plenty can go wrong, including impacts of interstellar dust, cosmic rays, and atoms of hydrogen. Commands could be sent as modulating information on the power beam, and findings would be uplinked to Earth by a compact laser using the sail area as an antenna. This audacious concept, its first phase privately funded, could return close-up images and sensor data of Proxima Centauri b, the first mission to an exoplanet. In the last few years, astronomers have had to completely change the way they think about worlds around other stars. Once assumed to be rare, exoplanets turn out to be extremely common. Small, dense worlds like ours, orbiting in the habitable zones of stars, are showing up more often in astronomical searches. Unexpected lakes and seas in our own solar system suggest that supportive conditions exist in astonishing locations. Ultra-cool dwarf stars may actually be better at building oceans on their planets than stars like our Sun. Ultraviolet light from flaring dwarf stars could stimulate the complex chemistry needed to jumpstart biology. Life may spring up in places that are nothing like our planet. And to them, we may look like the surprising outlier. But we evolved on Earth. Will we ever find any other world as beautiful?